We humans, we love to build. From the pyramids of Egypt to today's skyscrapers, we've always pushed ourselves to create bigger and better structures. Now, a new revolution is underway. Powered by 3D printing, this technology is rapidly changing how we make things. Unlike traditional manufacturing, 3D printing builds objects one layer at a time. This approach offers amazing design freedom. Imagine printing entire buildings on demand. This isn't science fiction, it's quickly becoming a reality. At the heart of the 3D printing revolution is fused filament fabrication, or FFF, one of the most widely used 3D printing technologies today. FFF is kind of like a hot glue gun hooked up to a computer. It works by feeding a thermoplastic filament, basically a thin string of plastic, through a heated nozzle. As the filament melts, the nozzle precisely deposits it onto a build platform, layer by layer. The plastic quickly solidifies, bonding to the layer below. The process repeats, guided by a digital design, until the entire object is complete. The simplicity and affordability of FFF have made it a favorite among hobbyists and professionals alike. It's used to create everything from prototypes and models to custom tools and even medical devices. But FF is also proving its worth in the construction industry. Early applications focused on printing smaller components, like architectural models and building facades. However, advancements in materials and printing technology now allow for the creation of larger structural elements and even entire houses using FF. One of the key advancements driving the use of FFF in construction is incorporating high-performance materials like carbon fiber. Carbon fiber is an amazing material, incredibly strong yet lightweight. It's made of thin strands of carbon atoms linked together in a crystal-like structure. Originally developed for the aerospace industry and Formula One racing, carbon fiber's exceptional strength-to-weight ratio has made it a sought-after material across various industries. Now it's making its way into 3D printed construction materials, taking FFF to a whole new level. By adding short carbon fibers to the plastic filament, manufacturers can significantly enhance its mechanical properties. These carbon fiber reinforced filaments produce 3D printed parts that are not only stronger but also stiffer and more dimensionally stable than those made with standard plastic filaments. Section 4. Building the future. Applications in construction. The use of carbon fiber reinforced FFF is opening up exciting possibilities in construction. Imagine printing lightweight yet incredibly strong building components on site, reducing transportation costs and waste. This is already happening. Companies are now 3D printing architectural details, formwork for concrete structures, and even complete modular homes using carbon fiber reinforced plastics. These materials offer several advantages over traditional building materials. They're resistant to rot, insects, and weathering, making them ideal for use in harsh environments. Moreover, the design freedom of FFF allows for the creation of complex geometries and custom building elements that would be difficult or impossible to achieve using conventional methods. This opens up new possibilities for architects and engineers to explore innovative structural designs and optimize building performance. Section 5. The promise and challenges of 3D printed buildings. The use of carbon fiber reinforced FFF in construction holds immense promise. It has the potential to revolutionize the industry, making buildings more sustainable and affordable. Imagine emergency shelters printed on demand. Homes can be easily expanded as families grow. However, challenges remain. Scaling up production is crucial. More research is needed to develop even stronger materials. Despite these challenges, the future of 3D printed construction looks bright. We can expect to see more and more 3D printed buildings popping up all over the world.